first step is to understand the problem.
Crap.
Oh no, I don't understand. Screwed.
I don't know why it's doing that to me. Where is that?
Two.
Yeah, right there.
There?
Ms. Faulkner, did you say there weren't going to be any asymptotes on the quiz?
Correct. Okay. Ready? Alright, so we're going to first understand the problem, which basically means picking out the important information, right? And then we'll basically draw a picture, okay? So, if whatever you're trying to find, use a variable to represent that, and then after you draw a picture, you need to write a function that you're going to use to find your answer, okay? So with optimization, we're trying to maximize or minimize something. So after you figure out what your function is, we're going to find the maximum or minimum of it, and so we're going to do that by finding the derivative and setting it equal to 0. We can graph the function just to make sure that we have a good idea of what the domain, the possible values of x are, because with word problems a lot of times there are certain constraints that we would have for the function. And then identify the critical points, so where is the derivative 0, where does the derivative fail to exist, that will be the maximum or the minimum, and also figure out where the endpoints are. Solve it, and then you can check your answer to make sure that it makes sense. Okay? Alright. So, an open top box is to be made by cutting congruent squares of side length x from the corners of a 20 by 25 inch sheet of tin and bending up the sides. How large should the squares be to make the box hold as much as possible? What is the resulting maximum volume? Okay, so first, what is important?
The 20 by 25.
Okay, we have a 20 by 25 inch sheet of tin. And what else? What are we doing with it?
A square.
Making a
Box.
box. Okay, and in order to make a box, we're going to cut congruent squares of side length x out from the corners. Okay, so we're going to draw a picture. So we're going to start with our 20 by 25 inch sheet of tin. So 20 inches by 25 inches.
That means a rectangle.
What?
Wouldn't that mean it's a rectangle, not square?
This is a rectangle. But we're cutting out squares out of the corners to make it a box. Because if you think about a box, right, if we cut out squares out of the corners, we can fold up the sides. And if we glued the sides together, we could make a box out of it. You know what I'm saying? I'll show you. Here's a rectangle. If I cut a square out of the corner, if I did that with all the corners, and fold it, then I can make it a box. Right? And it's a square. So if you do that with all the corners, we would make it a box if we glued it together. Okay? Does that make more sense? Yes? Okay. Alright, so that's what we're doing. That's what it's saying. This is a common problem that you'll see with this type of problem. So, which is actually pretty applicable, because if you're thinking about like companies that are selling their product and they want to use the smallest amount of cardboard to put their product in, but they want the most volume of the box, right? So there are people that would actually sit down and calculate this to try to figure out what size of box they should get to do that with the least amount of cardboard. Okay. Which is probably why most boxes for certain things are about the same size at the store. Alright, so we need to know, these are squares, and we need to know what x is. X is the length of the side of the square. Okay, so the question is, once I make this into a box, by folding up the sides, what are the dimensions of the box? So this is going to be like the length. This would be the width of the box. And the x would be the height. So how can I write an expression for the length of the box? If the whole side is what? 20. And each of these are what?
The height.
Right, which they're asking us to call x. Because it's this length of the side. So how could I represent L then, the length?
2x minus L.
What?
2x minus L.
20 minus 2x. Because the whole sheet is 20 inches wide, but we're cutting out two squares that are both going to be x from it, right? So what is the width going to be?
25 minus 2x.
25 minus 2x, which I didn't leave a lot of room for. And the height is going to be
X.
yes. Does that all make sense? Yes? So we're trying to maximize the volume of the box, right? So what would be the function for the volume of the box? Do you know how to find volume of a box?
Area base times.
Okay, and how do you find the area of a rectangle?
Base times height.
So it's going to be all three of these multiplied together. Length times width times height. So it'll be x times 20 minus 2x times 25 minus 2x. So that is my function. Okay, so you could graph it on we could graph it on our calculator to figure out generally what that's going to look like. We also need to figure out what the domain of this function is. So the x is the amount that I'm going to cut out from the sides. What's the smallest that could be? It's going to have to be bigger than what? It's going to have to be bigger than 0, we have to cut something out from the side, so it's gonna have to be bigger than 0. And it's gonna have to be less than 2 of them together is gonna have to be less than 20. So one of them's gonna have to be less than 10, right? Because I have to cut it out from both sides of the 20-inch side, so they can't be more than 10 each, or else I won't have anything left. Okay, so my x is gonna have to be a number between 0 and 10. Okay? You guys dead today? What's
It's
going on?
Monday and the brain doesn't work on Mondays.
I didn't leave enough room for this, so no. I mean, that's gonna be messed up. Sorry.
That's
Alright, so let's multiply out this so we can get the derivative and all that good stuff. So we're gonna have to multiply this out. Let's first do the FOIL part. So 20 times 25 is
500.
500 minus 2 times 25, 50x minus
4x squared. 4x squared.
40x
Which one are we on? Oh, I was doing the 2x's.
plus 4x squared, okay. So that will give me x, I'm gonna rearrange it, so 4x squared minus 90x plus 500. And so it'd be 4x to the third minus 90x squared plus 500x. Right? So the derivative is
12x cubed
12x
squared
squared
minus 180x plus 500.
Okay, good. And so we're trying to find the max, so we set that equal to 0. Man, I still didn't move that far enough. Fix that later. Okay, and then what would we do? Quadratic formula. So x will equal.
I thought you could take it out so fast so the numbers won't be so big.
We can. You want to? Yeah. What do you want to take out?
I'll take out more than that.
What will come out? 4? Will that be the greatest number?
I think so.
Yeah. This 12 would be, yeah. So 4 times 3x squared minus, does 4 go into? Let's see, 4 goes in 18,
45.
twice, so 2 left over. 25?
45.
Right.
185.
45x plus
125.
oh, Does 12 go into all this? No. Oh, okay. Alright, so 40, that'll make it a little bit smaller.
I should have. Yeah, I should. Guess what? I think I jinxed myself. Yesterday I was like, I haven't been sick for a whole month. This is a record. And I woke up this morning with a I was like, oh, that's I jinxed myself.
That's really what? I zoomed in.
Okay? So, what do you think about that? What?
That's our answer?
What's the answer?
Three.
What about 11.32?
It's bigger than 10.
Yes, right. So that's why we decided what the domain was at the beginning, because we can't have a domain bigger than 10. So it has to be 3.68. That is the length of the X. And they also asked you for the resulting volume of the box. So how would we find that?
I thought the volume was the V that we were solving for though.
We solved for the X though.
So we have to plug this back in
Yeah, to find the
to
V.
find the V.
So this is the X, that's the length of the